Hello and welcome to another video from Berkshire Guitar Amplifier Repairs. I'm Stuart Smith and today we're going to be looking at capacitors in old valve amplifiers. In particular, we're going to be looking at how to measure their value and how to check their leakage. There are two main sorts of capacitor in these amplifiers: the larger value electrolytics, which we won't be looking at today. To be honest with you, I just changed them if they're old. And the smaller value signal capacitors, which we want to retain as many of them as possible in the amplifier because people believe that they affect the tone. So we're going to be looking at the smaller capacitors and we're going to be checking their values and we're going to be checking the leakage current. So let's get right into it now and have a look at inside the amplifier. So let's have a look at the capacitors on this amplifier. There are two sorts really. These are electrolytic capacitors, usually quite a high number of microfarads. For example, these are 22 microfarads at 25 volts. These do the decoupling, signal decoupling for the cathodes of the 12AX7s. And they do go faulty on older amps. They must be replaced. There's no choice about replacing these. And also, whilst one's at it, we usually replace the smoothing capacitor for the bias circuit as well. As indeed, of course, we replace the top side HT high voltage electrolytics. But there are other capacitors on this circuit. These blue ones here, these discs here, I've replaced those, so take no notice of those. And these are signal capacitors. Now, purists say that one shouldn't really change the signal capacitors because it changes the sound of the amplifier. I would love to see an A/B test on that. I would bet a considerable amount of money that nobody can hear the difference between an old capacitor and a modern high-spec capacitor. But anyway, that's as maybe. There's another reason not for just willy-nilly changing all of these caps, and that is one wants the amp to retain its kind of vintage look. You don't really want to be stripping out its entire board and putting in whole new circuit, whole new capacitors, resistors and everything, because it's obviously not original anymore. So one wants to try to keep the amp as original as possible. Yeah, you might say you don't really like these non-color coded yellow wires here, so let's strip them all out and put a nice set of new color coded wires in. Well, okay, but the amp's getting less and less vintage and more a modern rebuild. What I'm really saying is we want to minimize the amount of work we do on an amp, not maximize it. There are several sorts of capacitors like this on these older amps. These are blue ones and they're usually fairly good. You don't normally have to change them. However, I think it is worth testing and checking the values and leakage of these capacitors, because it does make a big difference to the circuit if they are wrong, and indeed can cause some more serious problems. What we do when we check a capacitor is to check two things. We want to check the actual value of it to make sure it hasn't drifted too far off, and we want to check the leakage of it, because these are high voltage capacitors and they have DC across them, you know, maybe several hundred volts at this end and virtually 0 volts on this end. And if they leak, some DC current leaks through the capacitor and ends up where it shouldn't. Unfortunately, it's not particularly easy to test both of those things, but I will show you how to do it now. To test them, you have to lift one end. There's just too much going on in the circuit to just leave the capacitor in the circuit and go along and hope to get anything like a sensible reading. So on this capacitor I've just lifted one end from the eyelet there, and the first thing I'm going to check is its value. You don't need an expensive piece of equipment to do this. This little meter here, which I'll just prop up to get that glare out of the way. The trouble with these lights, you have to get it pretty much exactly right for you to be able to see. And and I think this was £15 on eBay, so it won't set you back a lot. This particular capacitor is 0.022 microfarads. That is the same as 22 nanofarads. Micro is 10 to the minus 6, nano is 10 to the minus 9. So 0.022 microfarads is 22 nanofarads. Now there's a 20 nanofarad setting on this meter, but that's not right, because at 22 nanofarads this will come back and say it's out of range. So unfortunately we're going to have to select the next largest, which is 200 nanofarads. It says 200 there. And I'm now just going to go on to the capacitor and see if we can get a decent reading of its value. Oh, well, that's pretty good. That's 20.2 nanofarads. So I'm happy with that. That's very well in tolerance. We need now to check whether it can stand up to a high DC voltage without leaking. And to do that, I use what's called a mega, used to test insulation. My one's rather old, but you know, I've had it for years, so there's no point in my changing it. And all it does is when you press this button here, it puts a very high voltage out on these two crock clips, which I've got connected to the probes. You don't want to grab hold of these when you press that. Of course, it won't kill you, but it'll give you a very nasty little shock. And you just clip one end to one side of the capacitor and the other end to the other side of the capacitor. Now when I press this button, it will put 500 volts across that capacitor, and the meter will tell me any current that's being drawn. In other words, it actually gives me a measure of the resistance. So that would be a short circuit there. In fact, let's just quickly short circuit the probes together now, and I'll just press that button and you see it goes up to a short circuit, and all the way up to 100 megohms. Now what I'd expect to see is when I press this button, I'd expect to see an initial flip of the meter as the capacitor charges up, then the meter to settle back to a very high resistance value of in excess of 50 megohms. So let's just see what happens. There's the flip, and it settles back nicely, and there's no leakage whatsoever on that capacitor. Literally zero. I can see there's not a tenth of a millimeter movement of that needle. So what we have there is a good capacitor. The value is spot on, and there is no leakage. Let me just show you one more, and I think you'll get the idea. So let me lift one leg of what should we pick? That one's underneath the wiring, which doesn't make our life easy. Oh well, we should be able to get it out. I'll go for this one here. There we go. It came out quite easily. So once again then, let's get our capacitance meter. This capacitor is, if I can see, 0.047, so 47 nanofarads. Once again we will go on the 200 nanofarad scale. There we go, hope you can see that, yep. And now I'll measure across this capacitor and we'll see how close to 200 nanofarads it is. Sorry, not 200, 47 nanofarads, and it's 52. So that's okay, that's not too far out. Happy with that. Let's now check its leakage by bringing in the mega. Clip across the capacitor. One clip. Where is it there? Two clips. Again, we'd expect to see this little blip of the meter, and then for it to settle down to in excess of 50 meg. There's the blip, and it's settled down, and again I'm close to the meter than you are, and I can see again it's not a tenth of a millimeter deviation there. So again, a perfect capacitor. In that way you can go along and check, there aren't that many of them, 5 or 6, and check for any problems and replace only if you have to. As I say, these blue ones are quite good. Some of the other ones are really shocking and will be very badly affected by age. They'll leak and they'll be way out of tolerance, and you have to change those with something like orange drop capacitors. Well, I hope you enjoyed that video where we had a quick look at the older capacitors in these 1960s, 1970s guitar amplifiers, and I hope you've got a little bit of knowledge now about how to check their values and the importance of leakage current. I'll catch you on the next video, and thanks a lot for watching.